So this is the briefing for the Borane experiment. At the top we've got the actual reaction scheme of what's happening in this reaction. You're taking a Borane THF complex, reacting it with an amine to form a Borane amine complex. So it's like a displacement reaction. Now this reaction, like a lot of reactions in synthesis, doesn't work in the presence of air and water. If there's any of that present, then the reaction sort of degrades. And so there's an important way in which we have to perform synthetic reactions without air and moisture, where we keep the reactions under an inert atmosphere. All the glassware that we use is dry. All the solvents and reagents you use have been dried as well, so there's no water or moisture present. And we have to transfer reagents and liquids again, instead of pouring them into measuring cylinders or pouring them into beakers where it's out in the open and can mix with water. We have to use syringes and needles instead to transfer them and keep them away from air and moisture. And so that's what key skills you're going to learn in this reaction, is how to perform a reaction under an inert atmosphere. You'll be using nitrogen to replace air and moisture in the air, and you'll be using syringes and needles to measure out and transfer the liquids in this reaction. And like I mentioned before, this is a really important technique that you're actually going to use for quite a lot of synthetic reactions, because it's quite common to actually need to perform reactions in the absence of air and moisture. And so in the pre-lab videos, we have a specific video showing you how to do these two important features of this reaction. Firstly, how to sort of set up your reaction, purge out all the air and moisture from the flask so it's not present when the reaction is taking place, and then how to transfer liquids using syringes and needles. And there's lots of subtle things and small details you have to do to get these things right, to make sure you get rid of every last bit of water from your reaction, because any water that's present is going to degrade your reagents or products, which therefore is going to lower your yields. So when it comes to drying your reaction and keeping it under an atmosphere of nitrogen, what you need to have is a rubber septum over the top of your flask, and then you have one inlet with a needle piercing through the septum that's going to sort of have a positive pressure of nitrogen. So this is going to stream nitrogen into your reaction flask, and then you're going to have an outlet needle as well, which is going to push out and purge out any air from the flask. So what you do when you set up your reaction is you have the nitrogen streaming through your reaction flask, and then what you do is you heat the flask as well, so that you're heating all the water that's kind of stuck to the glassware. You're heating it, turning it into vapor, okay, and then the nitrogen will push and expel all that moisture out of the flask and replace it with nitrogen gas. Then you let your reaction cool down back to room temperature, and then you've eliminated all the air and water from your flask, and you're ready to use and to start your reaction. Okay, and so when you're adding any liquids or reagents to this flask, you can't just open the septum, okay, and then pour in the liquids, because then you're exposing the reaction to air and moisture. What you've got to do is you've got to use needles, syringes and needles, to add your liquids, and so the reaction always stays under an atmosphere of nitrogen. And so how you use syringes and needles to withdraw the reagents that you're using, these are going to be dry reagents, dry solvents that you're using for these reactions. So again, you can't just open the lids to these bottles and expose it to air and moisture, otherwise they'll get wet. Instead, what you've got to do is you've got to add the nitrogen line to your sort of anhydrous reagent flask. It will have a rubber septum as well, and then through the septum needle you sort of withdraw the liquid that you need to add to your reaction flask. And there's little tricks that you need to do here to make sure that you also remove any air or moisture from your syringes and needles, so that you don't again mix your liquids with water, which is then going to add water to your reaction. So what you do actually before you withdraw any liquid is you first sort of pierce the septum. You don't put the needle into the flask, you just keep it here above the level of the liquid, and you just withdraw some nitrogen gas. Then you take the needle out, and then you purge the needle. So you're pushing out any sort of air and moisture from the needle, and you're replacing it with nitrogen gas. So you do that a few times before you actually withdraw the liquid. Again, watch the videos carefully, because they do go into detail of how you make sure you sort of remove air and moisture from your syringes and needles, and make sure you transfer these liquids correctly without mixing in or adding in any extra air or moisture. So the reaction itself is quite a short reaction, but it's a technically challenging reaction. Okay, so it's going to take a bit of time to sort of set up your reaction and add your reagents carefully with using the syringes and needles. Okay, but that's basically the bulk of the reaction. Once you've mixed your reagents, set up your reaction, you've added your reagents and stirred it together, then you've formed your product. You just need to sort of evaporate the solvent and crystallize the product at the end. Okay, so all in all, this whole reaction takes about 3 hours, like it should be timetable to run in your morning session of one of your lab days. Okay, so take your time to do this reaction properly, because if the longer you take over, you do this reaction carefully, you will sort of perform these techniques properly, and you'll get sort of better yields at the end. Okay, so in terms of the tips, as I've mentioned before, do follow and perform these techniques carefully. The second point is really important. Okay, we can't dispose of syringes and needles in the normal waste bins. Okay, we have to use special sharps bins. These are sort of hard plastic yellow bins that will be out in your bays. So make sure your syringes and needles go into there. And then this third point is also really, really important. Okay, needles have these plastic caps. Okay, when you've finished using your needles, do not try and put these plastic caps back on to the needles. In fact, most needle accidents that occur in the laboratory are by people who try to put the plastic caps back on, that they miss, and they end up piercing their fingers. Okay, so it is not good policy to put those caps back on. Just put the needles unsheathed into the yellow waste bin. Okay, so that's the full briefing for the Borane experiment.